Sige. So, hello class. We'll discuss today our katong last topic na to ang discuss. I'm going to recap those topics so para pod as well to mga absent maka-catch up. This is in preparation for your upcoming exam. So, these topics will be for exam 4 and exam 5. Sige. So, first, what we have here, we have continuity equation. So, continuity equation, this is actually used to analyze flow of the water, most especially sa pipes, no? So, the main, yung tawag dito, the main definition of continuity equation, this is only the conservation of mass. Continuity equation focuses on the conservation of mass regardless of its pressure o ganun. So, for example, here we have pipe 1, pipe 2. These two pipes are connected to each other, diba? However, the first pipe has a bigger diameter compared to this one. So, take note that the bigger the diameter the pipe has, it means that it has a bigger pressure. Meaning, mas dako ang pressure sa ato ang kaning nasa pipe 1 compared sa pipe 2. However, the mass that comes from the pipe 1 is similar sa mass na mugawa sa pipe 2. So, that is the continuity equation. What we have here are the formulas for compressible fluids and for incompressible fluids. So, we have here the mass sa compressible fluids is equal to density times the area times the velocity. So, we have density 1, area 1, velocity 1 is equal to density 2, area 2, velocity 2. So, this is applicable for compressible fluids. So, what are the fluids that are compressible? These are air, steam, more on gases na mga fluids ang compressible. The very reason that it is compressible because the molecules of the gases are very far from each other. That's why if pressure occurs, they have distance nga makompress pa sila. So that's why compressible fluids. So basically if there's a change in pressure, or let's say if there's a change in pressure, then the density of the fluid itself changes as well. Therefore, this is a compressible fluid. So, sa gas, sa steam, makompress man sila. So, compressible fluid. Next, we have incompressible fluids. These are water, more on mga liquid na ng incompressible fluids. Again, the very reason for that is that since 'di ba ang molecular structure sa liquids, though it is not as far as the gases itself, na siya space compared sa solids, pero dili siya far enough na makamove ang mga molecules when there's a change of pressure. So mao nang incompressible fluids. However, in reality, water itself can actually be compressed. Pero, the small kaya amount na mahimo siyang negligible na lang during computation. That's why, ang ato ang water, that's why incompressible gihapon siya sa ato ang computation. So, if you're going to go back, no, di ba na discuss na ako ng topic ay nga formula. This is the mass flow rate, right? Q is equal to area times the velocity. So that's why muna itong gamiton diri sa incompressible fluid. So A1 V1 is equal to A2 V2. As you can see sa atong compressible fluid, gi-apil ang density, no, din kani wala ano man. Again, kay di ba ang definition sa we consider that as a compressible fluid if naay pressure na ma-change, then ma-change yung density. That's why matter ang density sa compressible fluids. However, sa incompressible fluids, if naay change of pressure, pareha ani nga kanang from dako nga tubo padulong sa gamay na diameter, ang iyang density would be the same. So, ang atong incompressible fluids, dili na mo matter ang iyahang density. That's why kani ang ato ang formula. Sige, so that is for our continuity equation. Again, ang focus sa continuity equation kay ang iyahang mass. Ang mass na mosulod will be ang mass na mogawa sa ato ang mga pipe. So, our next topic will be Bernoulli's principle. So, what is Bernoulli's principle? You can read here the definition itself, but the very main core sa unsa ang Bernoulli's principle is the energy that comes in will be the energy that comes out. The first law of thermodynamics, we're going to recall, conservation of mass, na energy cannot be created nor destroyed, but it can only be transformed from one form to another. So, muni ang pinaka-core sa ato ang Bernoulli's principle. The energy is conserved. So, energy ani, energy nga magawas. So, atong formula, we have here, so sa atong formula, we have here the velocity head. So, this one is the velocity head. Kaning V over 2G. So, kumbaga, the velocity head focuses on of how much ang energy na contain sa fluid in a moving fluid. Sige, I'm going to repeat it again. So, the velocity head, ang very purpose, ang iyahang gina-measure is how much ang energy sa moving fluid. Therefore, that's why ang formula like kaniyang formula but na-derive ni gikan sa, nawala ko ang, dara. So, na-derive ni siya sa kinetic energy over the weight. So, tanan na formula dire kay gi-divide siya sa weight. So, this one, sa velocity head, this is kinetic energy over the weight. So, if atoan nang i-cancel, the formula of kinetic energy is 1/2 mv squared. And if we're going to expound the weight, it's mass times gravity. So, mag-cancellation ta. Therefore, ang magawas na alang is, asa na to? Kani. So, VI squared over 2G. Next, we have here the pressure head. So, this one is the pressure head. The pressure head is how high the water would rise because of the pressure. So, unsa kataas ang tubig, ang maabot sa tubig tungod sa iyahang pressure. Mao ni ang pressure head. So, it was being derived by it's equal to flow of energy over the weight itself. So, ang formula, by the way, sa flow of energy, this is only pressure times the volume over mass times gravity, which is the weight itself. Kit kani siya tanan gi-derive ni siya gikan sa pag-divide sa weight. Again, this is pressure over pressure times volume over mass times gravity. So, if atuan nang if atuan nang derive, cancel, manggawas ani kay pressure over the specific weight. So, I've shown this already sa class, So, try to ask your classmates sa notes if you want to learn yun sa pag-derive. Then, we have here next, the Z. So, Z is the elevation head, So, ayang definition or the very purpose why it's being included in Bernoulli's is that this answers how much the energy it has become tungod sa iyahang height. So, how much ang energy na nabutang sa ato ang flow because sa height sa ato ang height niya. Kabanti ka tong photo. Sige lang, makita ara na ninyo ron later. Unsa nga height ako ang pasabot. As well as sample problems. So this one solves the energy in, then kani mo'y energy out. So, mauna yung main core sa ato ang Bernoulli's principle. Next, we have energy equation with pumps. So, na may, di ba, we use pumps sa daghang butang, sa shower, sa swimming pool, and even aquarium itself, no? Na iban, gagamit ang pumps. So, ang pumps as well, we use this kanang para i-rise na to ang tubig no from one point to another. So, from this state, ato ang pasaka padulong ani na state o diri nga lugar. So, we use the centrifugal pump kani para musaka ang ato ang tubig padulong ire. Therefore, we could say nga we added electrical energy. Kaya kanina nakakuryente ni, magpansak mangutag kuryente ani. So, we added electrical energy para, and we exerted or we added electrical energy so that masaka siya. And because of that, our energy formula, when we're going to deal with pumps, the energy in will become the energy out. So, ang ato ang pump kay mabutang sa energy in. The head of the pump itself maoy energy in. So, take note, everything dire yung formula kay meters. So, heads up, meters, meters, feet, basta marag, yung unit kay unit of, tawag dito, unit of length. So, sa head of pump, kay mabutang sa energy in, however, napuntay HL. HL is the head loss. Sa ato ang, if you're going to analyze fluids, no, there will always be loss, head loss. Why man? So, head loss occur siya if na ay friction. For example, maagi ang ato ang tubig sa pump naman ay friction. Dayon, di makuha na atong energy. Dayon, if aside from that, di siya makuhaan kay, di ba, mas energy conservation. Di siya makuhaan, but mo transform siya sa another way. It can be a form of heat, it can be a form of vibration, it can be a form of sound. That's why sa kabantay mo nga sa ato ang tubo pag mugawas ang tubig langas. That is because ang flow sa ato ang water kay naga-vibrate, and that vibration will become a sound energy. So, since na-convert siya sa sound energy, di mahimo na siyang energy out. That's why atong head loss na adere sa ika-2. Sige. Kung paspas ra kayo akong pagstorya, i-pause lang back lang. Next, we have energy equations with the turbines. So, we have here 4B. O, muna na akong head, pasabot. Elevation. So, ang matter man guna, soon, we're going to solve, no? Saan pagkuha ni, pohon-pohon, probably during sa inyong board exam, or sa inyong review, ma-discuss man ni saan ni pag-solve, pila dapat ang elevation, sa if we're going to have a, kanang planta, nga na gani. But, this is just the basics. So, let's say, no, natay 4 bay dire, na dire nga to ang water, dayon, mabuga siya dire og tubig, dinaan atong turbina dire. So, sa atong turbina, di ba, if sa ato ang mga power plants gamit ng tubig, ang turbina, mao ni ang gamiton, nga, pag matuyok ni, mahimong from mechanical energy to electrical energy. That's the very purpose of turbines. Therefore, ang ato ang equation ani, since ang output niya is electricity itself sa atong turbina, therefore ang atong equation is H turbine will be the energy out. Head loss will always be the energy out plus the head of our turbine. Okay na? Sige. Sige. So, our next topic will be about, spelling na akong losses. Head losses. Sige. So, sa head losses, we have here, we have different formulas, no, sa head losses. We have Hagen. I'm not really sure how to pronounce this, but this Hagen equation, wherein HL is the head loss, Kani is the dynamic viscosity, L length, V velocity, specific weight, and diameter. So this head loss, the Hagen equation will only be used to solve for head losses given by the fact that the liquid flows through a tube, agi siya sa tube. The flow is laminar, then the liquid is a Newtonian liquid. So, what is a Newtonian? Wala na ako nabutang dire. So, what is a Newtonian liquid? No. Newtonian liquid, this is are the liquids na kana bitaw dili mausob even if mo-apply ta og force. For example of this is the water. A non-Newtonian liquid is katong ma-change ang iyahang viscosity if applyan nato siya force. Again, if we're going to say Newtonian liquid, mao ni ang mga liquid na if we're going to apply a force, dili mausob ang iyahang viscosity. Example ani water. An example of a non-Newtonian liquid is kanang if imo siyang applyan og force, mausob ang iyahang viscosity. Example, soap. Soap solutions, di ba? As we're going to rub a soap, it's either mulagkit siya kaayo, depende sa amount sa imuhang, depende sa imuhang pag-rub, di ba? The more you rub it, mas mabula siya. Mauso ba iyahang viscosity? Another example is butter. If, sige tag, kani-kaning anuhon sige si butter, like kapon, ginarub na to si butter, di ba, mo action siya melt, then most of ang iyahang viscosity. So that mao na ang non-Newtonian liquid. So ang Newtonian liquid is water, kanang dili ra siya mausob no matter how much you're going to rub it, no matter how much you're going to apply a force. Sige. So muni ang tawag dito formula for the Hagen equation. So again, this will only be used if ma-okay ni nga mga conditions. If the liquid runs through a tube, it's laminar, and the liquid is a Newtonian liquid. Then another is we have, by the way, just for information of everybody, no, the Hagen, very seldom lang to eh. Seldom lang kayo ni siya magawa sa problem, sa board exams. So, this is just for the knowledge of everybody, but not necessarily nga i-by heart yun, memorize ni, no? Kay less likely mangud po din siya ma-apply. But this one, the Darcy waist back, this is the very common na ginagamit, the very common na ginagamit sa tawag dito sa mga head losses na problems. So, we have here L, the Darcy friction factor, length, velocity, gravity, and diameter. So, for example, that Darcy friction factor was not given, Reynolds factor lang gihatag. So, F is equal to 64 over the Reynolds number given that it is a laminar flow. Kani, given na laminar flow siya. Then, aside sa Darcy, we have as well a famous formula for head loss. We have the Morse equation. As you can see, the two are quite the same, no? But this one, ang iyang 2 na sa taas, iyang 2 na sa ilalom. So, ang iyang F is Morse friction factor. So, when are we going to use Morse and when are we going to use Darcy? If the problem states specifically that you're going to use Morse, Morse ang gamiton. But, if ang given sa problem, yan ang giingon is friction factor, Darcy lang atong gamiton. Again, basta wala nang indicate ng problem if it's Morse or Darcy, atong default, Darcy. Pero, pag moingon ng problem og Morse, Morse atong gamiton. So, friction factor in Darcy is actually, was, tawag dito, it came from Moody diagram. It's very complicated na if I'm going to expound how to read a Moody diagram. Pero, kaso lang na mag-ask ang magawas paguro sa problem and anything, pohon if you're going to take the board, at least you know nga it came from a Moody diagram. So ang spelling sa Moody, no, kay kanang Moody, kanang typical spelling sa Moody nga person. Then next, so take note ta sa length, no, na ay length ang Darcy, naapod ang Morse. So, I will expand later unsa nga length ang iyang gipangita. So, next, nga formula for head losses. We have minor head loss. I-use lang nato ni if, aside from gi-state siya sa problem nga minor head loss ang gamiton, we as well use this if kanang na-fulfill sa problem ang mga given niya. Not all the time mo ingon man ang problem. Use Darcy, use Morse, use Hagen. 9 times na we're just kanang input na lang taba sa iyahang mga given ang problem. So if ever that you've encountered a problem nga na-fulfill niya ang iyahang mga given, di minor head loss atong gamiton. So, sa minor head loss, no, we have kV squared over 2G. So, K is for the resistant coefficient. If K is not given, and you know to your heart na minor head loss gid ni siya, kay aside sa, gingon siya, all of the given sa problem, fulfill sa actual formula. So, if that happens, inyong gamiton is 0.5. If not stated, ang resistant coefficient. Sige, so yung ganion. Next, we have different pipe connections, no, sa ato ang kung mag-connect ta og tubo. We have a pipe series in connection, then pipes in parallel connection. So the volume flow rate, clarify lang na ko, no, Q kay the volume flow rate. Ang M di ay nga katong dot mo toy mass flow rate. Nabali na ko. So Q, ang unsay mo gawa dire nga Q, maoy mo gawa dire. So ang mosulod na Q sa Q1 will have the same volume flow rate sa 2, and as well will have the same volume flow rate sa 3. However, the head losses maad-add siya. So ang head loss sa pipe 1, ang total head loss will be the head loss of pipe 1 plus the head loss of pipe 2 plus the head loss of pipe 3. So that is for the series connection. However, for the pipes in parallel connection, ang iyang QT kay total sa volume flow rate sa Q1, Q2, and Q3. However, sa iyang head loss, ang head loss sa total head loss, ang iyang head loss sa pipe 1 will be equal sa head loss sa pipe 2 will be equal sa head loss sa pipe 3. So, mauni ang rules sa ato ang pipe connections. So, next we have here, kanang sa equivalent length, no? If we're going to go back sa sa mga Darcy, sa Morse, even if we're going to trace back sa Hagen, it uses length. So, the length that was being indicated here is the equivalent length. So what is an equivalent length? Equivalent length is like the theoretical length sa atoang system, sa pipes. Not all the times, no, ang atoang pipe kay straight. Naay times na muliko siya. Using elbow, using T, using valve, muliko-liko ang atoang piping system. So, let's say nga sa atoang T, nagka-pressure drop siya og 5 kPa. Sa elbow, nagka-pressure drop siya og 10 kPa. Sa valve, nagka-pressure drop siya og 15 kPa. Therefore, to get the equivalent length of this nga mga system, we will add natay legend. Example lang niha, dili ni standard. Magdepende ni sa problem. So we have here sa kani ako ang example sa 5 kPa sa 5 kPa na pressure drop, it equals sa 10 meters. So sa 10 kPa, since 5 kPa net kani 10 meters, net 10 kPa ni, therefore 20 meters ni. Sa 15 kPa, 10 times 10 times 10, 30 meters ni. Therefore, to get the total equivalent length, we will get 5 plus 5 kPa nga 10 meters, so 5 plus 10. Kani kay yung length 5 straight raman ni, therefore 5 meters lang ni. Then 10 kPa, 10 kPa is 20, no? 20 meters. So 5 plus 10 plus 5 plus 20, 40 na. Tama ba? Okay, 20, then plus 20, 40 na. Plus 5, we have 45. Then sa 15, 10 plus 10 plus 10. Okay, 15 man yan. Every 5, 10 meters. So, the total of all of this, mao ang equivalent length. Sige. So, that's it for our topics for exam 4 and 5. So, study lang mo na, muhatag lang kong sample problems. Tomorrow, so, review lang, try to search more sa Google, sa YouTube, na naman po ni daghan nga mga examples na ilang ipanghatag. Sige. So, good night, everyone. Then, upload lang niya ako for more sample problems. Thank you.